first of all, I want to ask.
It's wonderful to be there.
Great to have you, sir. Ask the two of you, who are the experts, what exactly is the significance of this latest development? Of course, we've been hearing numerous experts talking about the significance, but still, sometimes it's a little bit confusing. So let me have some very clear words from you first. Robert, you want to go first?
Oh, yes, sure. I think it's hard to underestimate how important this is. Einstein learned is that apart from light, there's another way to look at the universe, and that's through space itself. Space can curve, that's what we call gravity, but it can also vibrate and it can produce waves. And so this moment in the history of science, I think, can be compared to when Galileo first pointed his telescope and looked at the moon and the stars. We actually have a new way to look at the universe, basically by observing ripples in space itself. And this will be a tool for us to observe anything that doesn't emit light, whether it's black holes, whether it's the beginning of the universe itself. We basically have a totally new way to observe the universe, and I think that's extremely exciting. I think we all sometimes think, I just wish I was alive when the great revolutions of science took place in the 17th century or in the time of Einstein. We are living actually in a revolution right at this moment. We are learning how the universe works, how it was made, and where it's going, and that's terrific.
Well, Mr. Zhang, I'm sure you are just as excited as Robert, but Fan, tell me, what would that mean for the layperson? Yes, you would say, besides the electromagnetic waves we have used before to discover further about the universe, we now have a new tool. But how much would this new tool help us? Do we really know? Or are we overexcited already before we know anything further about it?
No, we cannot be overexcited about this. So as Robert mentioned already, so this is a completely new window on the universe. So astronomy is one of the first sciences we have as a human race. And from the beginning, we only have one channel to look at the universe, and that's electromagnetic waves. And now we have gravitational waves and also neutrinos coming up. So there's we're not just doubling, we're tripling the ways we look at the universe. And also for layperson, you know, if you're a fan of science or even science fiction, this will interest you. It's the one thing, the basic fundamental science. And in terms of practical usage, I guess that's the question that you were really asking. You know, if you, I'll go crazy first. So if you watch Interstellar, the movie, right? So there's gravitational waves is used for interdimensional communications. And also there's a really famous Chinese science fiction called Three Body. And in there, gravitational waves is also used for communication. And also you
have... But that's science fiction, come on. You cannot use science fiction to prove that the possible development you are going to have in the future in real science. This is different. In the future.
But more immediately, stuff that's the spin-off technology of LIGO can be used immediately in our to improve our daily lives. For example, so LIGO is basically a measuring device for distance, a very accurate one, which means the whole thing has to be stabilized against movements of the ground. You can't be jiggling like that. So there's something called the vibration isolation system developed for LIGO, which is the most advanced thing in the world. And when can you use that thing? For example, if you're doing microchip manufacturing, when you're making those tiny little conducting lines in there, nanometer lines, you really don't want the workbench you're working on to jiggle like that. There's no way you can achieve any precision that way. So, for example, this sort of
that is only one of those enormous amount of examples that how much of this further science contribution, science discovery could contribute to the daily life of the layperson. Having said that, though, Robert, would you like to explain to us how much potential and what is the speed of research we are having? I mean, it already takes 100 years after Mr. Einstein come up with this really general relativity theory. So how much would this technology or this new discovery really help us? In what speed?
Well, first let me remind you, when Einstein made his theory of relativity, he didn't dream that we would be using it every day when we use our GPS. Without Einstein relativity theory, we would mislocate our directions with a few kilometers every day. And so what we've seen, that technology has advanced to such a level of sensitivity that all the intricate details of nature and of how the universe works will start to matter for us. So I'm sure that in 100 years we'll have terrific applications of this technology. But I think more important is that we are getting a sense of what is the universe we are living in. And up to now we have basically been blind to many important developments. It was a great shock for all of us when the first measurement came in that it was this extremely violent collision of two black holes. These black holes apparently are out there. They are determining the universe. In fact, they're determining how we all came to being. And so I think apart from the terrific technological developments, the most important thing is we get a sense of where we are. What is the universe that we live in? And we also are realizing what we do not know. It's just, if you can't see it, it doesn't mean it's not there.
Right.
And we basically got another pair of eyes to watch the universe.
Right. But Robert, may I continue to ask you, because it really takes us a long time to find the electromagnetic waves to begin with. And then it also takes us 100 years
Yes.
to prove what Mr. Einstein said already about the general relativity theory. And this specific gravitational waves is a new discovery. However, how many other discoveries we still need to have before we understand really the universe? So what I'm trying to say here is, Robert, how much do we know about the universe to understand that gravitational waves is really contributing to our understanding of the logic, the real logic of the universe?
Well, it's important to emphasize this is the first of a long series of discoveries that will come fast. Gravity is the perfect way to study the universe because Einstein told us gravity measures anything that has mass and anything that has energy. So there's no way you can hide for gravitational waves. It's a completely comprehensive view of the universe. And we know that there are many elements in the universe we do not understand. Roughly, we understand only 4% of the content of the universe. 96% we call dark matter, dark energy. We have basically very little idea how the universe was born because we cannot see the very beginning of the Big Bang. Gravitational waves have the property to pass through everything. So they are the perfect way to measure all these phenomena. And the great thing is that there are many experiments going on. This first discovery was basically made before the experiment was turned on. It was still in the experimental run. It's like you go on a safari and already in the parking lot you see a wonderful animal. So I think we will see very rapidly in the coming years many, many exciting discoveries that totally will transform our understanding of the universe. And in fact have the potential to ask and answer the really deep questions. In particular, I think the biggest question of all, how did it all start?
Right. But how many animals, the beautiful animals, do we have to see in the parking lot in order to figure out?
Quite a few, actually. There are a lot of things we don't know about the universe. So first of all, well, this theory-wise, general relativity and quantum mechanics still doesn't work together. More practically, as Robert just mentioned earlier, 95% of the universe is something we don't know. For example, I want to follow up on the dark matter thing. So dark matter is something that's in the universe that doesn't interact strongly with other sources, other sort of forces apart from gravity, which means it doesn't emit light. It doesn't emit much light.
Right.
So it's very difficult to observe them using the traditional methods. But gravitational waves opens this completely new window where we can actually look at those things, see how they evolve, and really understand what they are. We don't know what they are, basically. Our standard model for particle physics don't have them. So So basically, we now have something to look at them.
Right.
That's a complete, that's a jump. That's not just gradual change.
That is exciting, but we've seen some interesting development. For example, in the United States, that's where the announcement was being made.
Right.
We also have these kinds of LIGO systems inside India, inside rather Italy and also Japan at the moment. And in 2 years, some say India is also a possibility. And some also suggest in China, as you already got a lab in Beijing Normal University regarding gravitational waves. So what is the latest development here in China? What is the role of China contributing to the overall world research?
Okay, so China.
Big announcement, it seems like.
Right. This thing. I was tasked by my department to flash this in front of the camera.
Okay. All right. Enough promotion.
So that's so there's a lot of interest in China in gravitational waves. So I flashed that thing because last year we have organized a meeting that talks about the possible technology for next generation detectors that happened in China, and then the result is summarized in this particular journal. You can look it up online. It's free.
What exactly is the role? What exactly is the role?
What exactly is the role? So basic summary, we have very limited role. So we have, on the theory side, we have some people, tens of people, not hundreds of people, in Tsinghua, obviously, Beijing Normal University, and some other universities, Huazhong University, Zhongshan, and Chinese Academy of Sciences. But most of the people work on gravitational wave related topics, not 100% on gravitational waves. As a theory side. On experiment side, we're very lacking. So basically, there's no current dedicated gravitational wave observatory currently operating or under construction in China. I don't think there is any preliminary study that's currently being properly funded. But nevertheless, people have been making proposals. They've been making preliminary studies. Tianqin, that's mentioned in the short piece earlier, is spearheaded by Zhongshan University and Huazhong University of Science and Technology. There are other things that the Chinese Academy of Sciences is doing.
I see. Let me ask you, is it possible to have international cooperation involving China? Is China willing to join? Are others willing to have China join?
So Tsinghua is already a member of LIGO, and my university myself is part of the Japanese detector called Kagura. So yes, on the scientist level, collaboration is greatly welcomed, and we feel very, very welcome as well. But of course, when things come up to political level, then hurdles may arise. But we haven't gone to that stage yet.
Okay. Robert, do you think we are facing the danger that maybe at the political level in the near future, as more discoveries are being progressed, there might be difficulties for countries to cooperate?
No, I think it's the opposite. I think actually this is a wonderful opportunity to collaborate. And I think actually there's a very good reason for this. We need more gravitational wave detectors because only with many detectors can we actually pinpoint where the gravitational waves are coming from. And so the strength of this experiment is really to combine various instruments at various places in the world. And only then we can actually also combine gravitational waves with observations in visible light and radio waves to actually see what's going on.
Right.
So I think this is a terrific opportunity to really build a laboratory that's worldwide and where the various countries are collaborating. And China has such an incredible knowledge in terms of the technologies that are needed for this. I think would be a perfect fit for China to join this international collaboration.
All right, before we go, I want to have one sentence from each of the two of you about what exactly do you think would be the most exciting thing that we discover gravitational waves for us to see about the universe? Fan? One sentence.
I'm an astrophysicist, so I want to see I want to study the space-time dynamics near the black holes. How do they evolve?
All right, Robbert.
I think I want to understand why and how black holes have formed at all in the very beginning of our universe. And I think we'll get an answer pretty soon.